So, what's good, coders? Welcome back. Last episode, we taught Python to repeat itself with loops. Massive upgrade. But here's a new problem. What if you need to use the same code of logic in five different places in your code? Are you seriously going to copy paste it five times? Absolutely not. That's messy. That's chaotic. And honestly, that's a crime against the clean code. Enter functions. Reusable block of code you build once and call anytime you need them. This is episode 8 and it's about to change how you write the code forever. Let's get into it. So, first, quick recap. Last time we covered for loops, while loops, break, and continue. If that's shaky, rewatch episode 7. Otherwise, we'll move on. So, it's theory time. First question is what are functions? Think of a function like a vending machine. You put something in, that's your out input called a parameter. The machine does its thing and it gives you something back. That's your output or the return value. You don't need to know how the machine works internally. You just use it. So here's a bit basic syntax as def means define the functions. Create is the function's name. The parentheses can hold inputs. The colon and indentation work exactly like if statements and loop. Same rule, Python's very consistent about that. Now let's add parentheses input the function can use. Same function, different results depending on what you feed it. That's the entire point of it. Write a logic once, reuse it infinitely. So far, our functions just print parentheses stuff, but usually you want a function to actually give something back to so you can use it elsewhere. That's what return does. Here's a big difference. Print parentheses just displays something on screen. Return actually hands the value back to wherever you call the function. So you can store it, reuse it, do more math in it, whatever you want. Next up, default parameter. Sometimes you want a fallback value if nobody provides one. And key arguments passing values by name instead of position. So order doesn't matter. Same output, totally different order because we told Python exactly which value goes where the using Python parameter. Yeah. One more concept, scope. Variables created inside a function only exist inside that function. They are called local variables. Try to use them outside and Python has no idea what you are talking about. Variable created outside any function are global, accessible everywhere. Just keep in mind what happens in the function stays in the function. Now comes the exciting part. Let's build some functions with actual personality. Example 1, the excuse generator machine. So we'll just declare our first functions as generate excuse. And we'll give the reason why we just created a function here because of the traffic. Now in this function we'll just return sorry I'm late I got there was a reason. So what's our reason here? It's traffic. Now we'll exit our function and print our generate excuse. And what if we want to change our excuse into something new? For example, if I want to print generate excuse, but our reason has to be different. So, for example, I just give it a family emergency, or my alarm didn't go off. These are the like basic ones we use. Now we'll just our code here and see the answers. So for the first print statement, we are having sorry I am late. I got stuck in a traffic. And the second print statement gives the output as sorry I am late, there was a family emergency. One function, infinite excuses, this is basically a productivity tool at this point. Example 2, the crash compatibility calculator. So we'll have a first function as check compatibility. We are giving our parameters as your score and their score. Now we'll have our difference, which is your score minus their score. It will give the absolute value of the difference of your score and their score. Now we'll use the if condition as if difference is smaller than 10, and if the difference is smaller than 10, it will return highly compatible. Now with the elif condition, we'll just see if the difference is greater than smaller than 30. If it is true, then the return statement will be it could work with effort. Then with the else statement, it will return respectfully done. Now we'll uh, assign the values to the parameters, which is check compatibility, and my score will be 85 and their score will be 70. And we'll just print the result. And now I'm gonna run the code. So you can see it is highly compatible because my score is 85 and their score is 78. So its difference will be 7, and the 7 is smaller than 10, so it will return a high compatible. Here, Habs parenthesis gives the absolute value. I have told you that. So it doesn't matter who scored the high, just how far apart you are. Built-in function and custom functions working together. Look at that teamwork. Example 3, the bill splitter. First, we'll have a function as split bill with parameters as total people and uh, tip person, which will set here only, which is 10. So in function will set the tip as total into uh, tip percentage by 100. So the tip will be the total into the tip percentage by 100. Now the final total will be the total plus tip. And as it is a bill splitter, so the per person expense will be final total divided by people. As people is the parameter, so we already will set it later. And then I'll just return the per person, and it will be a round of now the amount each each amount will be split. So total will be 1200 and the and total people are 4. So now I'm gonna print the value as if each person pays which is amount each. Now we'll have another variable as amount each generous as split bill, which is 1200 and total people will be 4. But here we'll change the tip percent, which will be 20. Now we are more generous than above, so we'll have a tip percent of 20 and we'll print the statement here, which is if with generous with a generous tip and amount generous. So now I'm gonna run the code and see our output the each as each person pays 330 rupees with generous tip. Each person will pay 360 rupees. So you can see here is our function which has three parameters, which is total people and tip person, which is we actually set it as 10. So the tip is equals to total into tip percent by 100, which is total as we have taken here 1200. So 1200 into tip percent, which is 10 by 100, which is 0.1. So it will 1200. Sorry, 120 as tip. Tip will be 120, and the final total will be 1200 plus 120, which is 1320. And the per person bill will be 1320 by the people by total people, which is 4. So 1320 by 4 will be 330. So here is the total calculation how it is done. And if we are more generous, so we just set the tip percent as 20. Now the calculation just changed and the per person split will be 360. This is the exact logic behind every bill splitting app. Default tip of the 10%, but you can override it. And if you are feeling generous, or if you're definitely spilled something on the waiter. Example 4, the scope trap demo. Our first variable is mood, which is excited, and we'll have a function as change mood. Here there are no parameters. We don't need any parameters for this function, and we'll change our mood to chill. Now we'll print the statement, which is f inside function mode is our mode, which we have set it in the inside the function. So we'll just call the function here and we'll just uh, we'll just print the function we'll just print the mode which we have set outside of the function. It is a very good example of a global variable, as mood equals to excited is the global variable, but mood equals to chill is a local variable which is inside a function. So if you're printing this variable inside a function, it will give chill. As if I'm gonna run the code, we'll just have the answers. So inside function, mood is chill. But if I if I print it outside, so the outside function mood is still excited. See that the function's mood and the outer mood are the two completely different variables. That just happens to share a name. This trips up everyone at least once. Now you know why it happens. Your turn. Pause it, try these, and don't peek ahead. Problem 1. The greeting machine. Write a function greet underscore user with the parameters as name, time of the day, which is already set as morning. That returns a greeting like good morning, Alex. Call it once with just a name and once overriding the time of a day. Comment down the answer in the comment section and I will check the answers. Problem the grade calculator. Write a function calculate underscore grade with a parameter as marks that returns A if the marks is greater than 90, B if it is greater than 75, and C if it is greater than 60. Else returns F. Test it with three different marks values. Answer me in the comment section, and if you have any problem, the answer is in the description box, but try it yourself first. Problem 3. The tip calculator. Write a function calculate underscore tip with parameters as bill underscore amount tip underscore percent, which is already set to 50. That returns the tip amount and the total bill. You can have a hint too here. You can return two values as a tuple. Okay. Print those values using tuple unpacking. The tuple unpacking we have already done in episode 4. So if you have any doubt, go visit episode 4 and come back and try this question. And if you have any other problem than that, you can check the answer in the description box. But first try it yourself and comment me the answer below. Problem 3 combines two episodes worth of knowledge, functions and tuple unpacking. If you nail it, you are officially cooking. Comment your results below. So now, quick recap. First, the functions are reusable block of codes defined with def called by name. Second, return sense of value back. Print parenthesis just displays it. Third one, default parameters give fallback values. Keyword arguments let you pass values by name. Remember what are parameters and arguments. Fourth one, scope matters. Local variable inside a function doesn't leak outside it. There's a big difference between global function and a local function. Local variable doesn't work outside the functions. You know now how to build your own reusable tools instead of just copy pasting code forever. This is genuinely one of the most important skills in programming. That's a wrap on episode 8. Next up, exception handling, where we teach Python to fail gracefully instead of crashing and burning every time something goes wrong. Try, excerpt, and friends coming next up. If this helped, smash that like. Subscribe if you are new and drop your problem 3 trip calculator results in the comments. Keep coding, keep vibing. I'll check you in the episode 9. Peace out.